Alright, we're going on our third video of factoring. This is probably more factoring than anyone should have to endure, but hopefully we're hanging in there. This is a good review. I don't expect many of you to get to the third video, and that's fine. Let's go ahead and work through these in case anybody is really interested in getting the practice. So 16 gives us an interesting idea here. We notice every term has an x in it. So I need to factor out an x first. We do not know what to do if we have that x cubed there, but once I take out an x, it reduces each of those terms by 1x. And now as I look inside the parentheses, I've got a trinomial I know how to factor. So I'm going to deal with that thing inside there. And let's maybe do this. We'll call that orange, and in that orange part I've got a negative 21, and the factors of negative 21 that add to be 4 are positive 7 and negative 3. So the orange part factors to x plus 7 and x minus 3. And we still have that x from in front. And there's your final factorization. How fun is that? Alright, similarly, looking at 17, we notice everything is divisible by 2. So you could do the master product, get 180 and find the factors of 180. But if you take out a 2, if you factor out a 2, now the 2 doesn't go away. It comes out in the front. Let me get this thing out of here. Get out of here. The 2, and then 18 divided by 2 is 9x squared minus 4x minus 5. Now it's not much prettier, but it's a little bit better. And let's use Mr. Orange again. So we're going to factor this thing inside as if that's all we had. So where before it was the easier one, this time it's the more difficult type. So we're going to look at our factors of negative 45. Our factors of negative 45 that add or subtract to be negative 4. You could start your list. Let's just make the list again. So 1 and 45. It's not even, so 2 doesn't work. It is divisible by 3. 3 and 15. It's not even, so 6 doesn't work. It ends in 5. Sorry, I should have checked 5 first. It ends in 5, so 5 and 9. And these are your 2 that we're gonna use. So the 2 comes down. Oh, wrong thing. Sorry. The 2 comes down. We have our parentheses. And I'm going to replace that negative 4 with a negative 9 and a positive 5. I'm going to put the negative first. So I'm going to call this 9x squared minus 9x plus 5x minus 5. And it gets a little funky with the parentheses here, but we have one, we have a group of 2 in front, we have a group of 2 behind, and we're going to take out the common factors. So in that first group of 2, I'm going to take out a 9x, so I get x minus 1. In that second group, I probably should have used to do a color. In the second group, I'm going to take out the 5, and I get x minus 1, so that's good news. We have a common parentheses. Now don't forget that 2 is still there, so I'm going to round up all this with that 2. And then I'm ready for my final factorization. We have a common factor of, let's see, how about blue? We have a common factor of x minus 1. I'm going to write that first. X minus 1. We have kind of our if you will, our leftover ideas or our numbers in front. So 9x plus 5. And that 2 comes down, but I've already kind of taken care of those parentheses. So it comes out like that. And as weird as that is, that's your best factorization on this. That's a tough one. That's kind of, you know, Algebra 2 material in some places. So. Alright, if you need to pause and rewind, that might be a little more than what we'd expect on the test, but it is fun to do, that's for certain. Alright, let's go ahead and look at 18. 18, we notice there aren't 3 terms. Then we think to ourselves, we should always think, is there a common factor? There is. If you don't think that first, with 2 terms, you should look for a difference of squares. But here they both have an x and they both have a 3. So the 3x comes out front. The 3's reduce, x squared over x becomes x. The 15 and the 3 reduce to give you 5. The x's go away. And there's your final answer. How about that? That was much easier than the one before, wasn't it? So that's the thing with factoring. You got to be prepared to go from the hard ones to the easy ones, from the difficult ones to the more straightforward ones. Alright, let's move on. 19. So it'd be nice if there was a common factor. We notice 9 is only divisible by 3, 8 is only divisible by 2. So no common factor. We're going to find our master product. 8 times 9 is 72. That's pretty big. I can list all the factors if you want, so even if you don't want, huh? 2 and 36. Since it should be clear 36 is divisible by 3, so 72 is also. It's going to be 3 and 24. You're welcome to use a calculator on this. It's divisible by 2, and that left us with an even, so that means it's divisible by 4, which is 18. I know half of 36 is 18, that's how I got there. It doesn't end in 5, so 5 doesn't work. But it's divisible by 3 and 2, so 6 will work. 6 and 12. We could continue on, but there's only one more, and we don't need to. 8 and 9 is the last one. So listing all the factors can be a little tedious, but it might be helpful. 6 and 12 are the 2 things that are going to give us 18. So as we come back up, we're going to rewrite 18 as plus 6x plus 12x. And now we're going to look at our 2 groups of 2. That little hieroglyphic there is an 8. Oh, that's lovely now. So we notice that in our first group, we can factor out an x and a 3. So I'm going to divide out a 3x. Factoring out and dividing out are kind of the same thing. Sometimes I show this work, sometimes I don't. The 9 and the 3 reduce to a 3. X squared over x is x. 6 divided by 3 is 2. The x's reduce out. And then in our second parentheses, our second group of 2, they're both divisible by 4. So be careful. Don't just take out a 2. If you don't take out the right number, you won't get identical parentheses. So we got to take out a 4. If you needed help, you should remember to get a 2 in the end. 8 divided by what gives me 2? 8 divided by 4. That might help you get the right factor out. And now we have our common parentheses. 3x plus 2 is our common parentheses, so it's going to go, I write that one first. And the second set of parentheses is, let's do this one. 3x plus 4. So we get 3x plus 4, and there's your factorization. So, quite a thing there. Alright, moving on. So this one sure looks like a difference of squares. We got a perfect square in front. We have a perfect square in back. It's tempting to say x plus 5, x minus 5, but remember it is a difference of squares. A difference, and we don't have a difference of squares, we have a sum of squares. So this does not factor, or it is prime. If you say, but I remember it's supposed to be x plus 5, x minus 5. Well, x plus 5, x minus 5 boils to x squared minus 5x plus 5x minus 25. So because of this is minus 25 and that other one is plus 25, it doesn't work out. So this is not the factorization. This is the answer. All right, again, I encourage you to pause it and try it, and then come back, turn it back on, and check your work. So looking here at 21, there are only two terms, so we should always check for a common factor first, but a two-term polynomial will be most likely a common factor or a difference of squares. So here I notice they're both divided by 7 and they both have an x in it. So I'm going to factor out a 7x. So 7x comes out front. What we see with 7 and 14 is that we're going to have a 2 left. And with our x's, we're going to have a x squared over x is x. And then what we see on the 7s is everything reduces. Now that doesn't go to 0, it goes to 1. So 2x plus 1 is what's in the parentheses. You should always be able to FOIL this back out to see if it works. It's a good check. Alright, running out of time again. We may not get all this done. Okay, I'm going to try to move a little faster, so you definitely might need to be quick on the pause button. 22, this is a 1x squared. This is our easier ones. Factors of -7 that add to be 6, -6, or -7 and 1. -7 plus 1. So these are easy type, two sets of parentheses, x in front. Fill in those numbers. And that's it. Bingo. Alright, 23. Sorry about that. Going a little fast, aren't I? Pause if you need to. 23. Um, 16 is a perfect square, 36 is a perfect square. This could factor as a difference of squares, but it's probably more important, or it is important, to recognize they're also both divisible by 4. If I factor out a 4, I'm left with 4x squared minus 9. Now, if the first thing was a difference of squares, after you factor out a common factor, you should still have a difference of squares. So, difference of squares factors to two sets of parentheses, 1 plus, 1 minus, and we put in our square roots. So square root of 4 is 2, square root of 9 is 3, 1 plus, 1 minus. And don't forget to bring down that original 4 out front. And there's your full factorization. So again, the 3 comes from the 9. If you need to pause, go ahead and pause. Alright. 1 minute. 45, yeah, 1 minute. So this, as we look at this last one, we notice they're all divisible by 4 again. How convenient. So I want to factor out a 4. I get 4x squared plus 12x plus 9. I notice here that I have a perfect square in front and a perfect square in back. I'm going to check their square roots. So I want to check 2 times the square root of the first times the square root of the last. Is 2 times 2x times 3 equal to 12x? It is in my universe. So 4 stays. It factors to square root of the first. Use your sign, square root of the last, squared.